This week, we finished up our lecture on word processes and modeling, and we started with a brief review on lexical entries because there was something that probably needs to be reiterated because I didn't emphasize a lot of it. So when we have lexical entries, we have different types of lexical entries based on which model that we're using. So if we are using the Morpheme-based model, our lexical entries look a little bit different than if we're using the word-based model. So imagine I'm trying to model, or at least discuss, the word jump and the word jumping. So how these words are formed. In the morpheme-based model, morphemes exist. So what we can do is we can say, okay, we have the pronunciation, we have jump, we have this phonetic component. It is a verb, and the meaning is essentially to jump. Okay, but we can also give an entry to the morpheme ing. So we can say for ing, it's something that attaches to verbs and it has a progressive meaning. And then what we could do is we could take these two lexical entries and we could combine them together and form a tree. So we have jump, we have ing, jump is a verb, ing is an affix. They form together to make jumping. Now, in the morpheme-based model, if you're looking at words, of course they have categories, but if you're looking at morphemes, you're seeing what they attach to. So you can introduce restrictions. With the word-based model, if we want to do jump and jumping, we can't talk about morphemes. Morphemes don't really exist. Specific morphemes like affixes don't really exist. Word forms exist. So we could have a word form jump. And when we do this, again, with the word-based model, we don't put the syntactic restrictions on a different line here for, say, a verb. And this is because we're dealing with word forms. Every pronunciation is a word in this model, and all of those things have categories. So the verb is part of this pronunciation, that verbal meaning. So then we just have a second line here, which would be to jump. So that would be the lexical entry for jump. And then when we want to do the jumping, well, we can't just do ing on its own. We have to do jumping because we're just looking at words. So this would be jumping, and this is a verb. And this would be jump. And then you could even write like this is the progressive form of it. So I just mentioned this because in the assignments, you'll see create lexical entries for things with the word-based model or the morpheme-based model. So depending on which you're asked to do, the lexical entries will look different. And that's because the assumptions of the models are different. So on the left, morpheme-based, affixes are their own morphemes. They have restrictions. They can choose things. With the word-based models, we're just looking at whole word forms. So like the difference between x and xing, where x is a verb and xing is also a verb. So there's nothing that lets us just write an entry for the in, the ing itself, like we can in the morpheme-based model. Okay, so with that being said, we started to look at other word formation processes. So some languages do this thing called lengthening. So we have this little symbol in IPA, which means that the previous sound, either vowel or consonant, has been lengthened, which means it's held longer. Japanese has this built into their words. So like in English, there's no difference between happy and happy. But in Japanese, there's a difference between kita and kita. So the length of the consonant matters. So some languages will have, say, one form. Let's say, for example, they might have the present with just e, but then for the past, they might make it longer and go e. Same could be said for consonants. So when consonants lengthen, it's called gemination, and when vowels lengthen, it's just vowel lengthening. So English actually has some morphophonological processes where we see lengthening. It's more of a result of two morphemes coming together. It's not really there's no contrast between a long sound and a short sound. But when we have these negative prefixes like un and in, and they attach to another base that has that same sound, that n sound to start, it's held a little bit longer. So un plus natural doesn't just make unnatural, it makes unnatural, 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 unnatural. You can hear the difference. Innumerous versus innumerous. Most speakers will hold that N a little bit longer once the two morphemes have joined together. As far as other processes, reduplication is a very interesting process. So with reduplication, sometimes an entire word repeats, or maybe just part of a word, to create a new meaning. So what we have here is an example of full reduplication. So in Afrikaans, if you take a word that is like an adverb or an adjective or a cardinal number like 3, a determiner or quantifier, however you want to look at it, and you repeat the whole thing, you get a new meaning. So adverbs and adjectives get this very meaning. So if you say amper is nearly, then amper is very nearly. Well, if you do it with a cardinal number, like 3, you would get 3 at a time. So it's like groups of 3 people going. Now, we kind of have this in English. Like, for instance, if you say, I'm arriving soon, and someone says, how close are you? Like, you can say, oh, I'm close, which means like I'm really close. But we don't really have this case where we have this 3 at a time meaning with numbers. So it's nice to see something different. But what it also means is that in a language, you can use reduplication to give different meanings depending on whatever categories you're doing reduplicating on. It's not going to work for every category, but you don't have to have reduplication always meaning the same thing. So if we just analyze what's happening here, let's say we have a word form. We're just repeating that word form. So if we want to model this, we could say, okay, we have some base word form X, whatever that is. We're doing the word schema for adverbs in this case. And when we want to turn it into very X, we're just repeating the whole thing twice. So we're going to XX for the adverb. We can do this with adjectives too, and we can do this with the cardinal numbers, but if we do it with the cardinal numbers, we have to change the meaning at the bottom. So that's full reduplication. We just take the whole form X and we switch it with XX, we reduplicate it. But we can also have partial reduplication. So in Motu, we have tau, which is man, going to tatau, which is men. So we're getting a difference of plurality, so singular to plural, and the whole thing is not being reduplicated, only part of it. So we're not doing tau, we're just doing tau. With the case of boy going to boys, so marrow becoming marrow, we're not getting marrow here, we're just getting marrow. So the first bit is copied. So that's one type of reduplication. So we have partial reduplication, and this is showing the difference between singular and plural. But we also have another type of reduplication here. So for instance, look at marrow, little boy. Well, marrow is boy, marrow is little boy. So if we do full reduplication, what we get is this little meaning. Now, what happens if when we do them both together? So you get little boys. So we have the little meaning and the plural meaning. We get mamero. So we do get reduplication of the whole word, but we also get reduplication of, well, partial reduplication there for the meh part. So we can do two types of reduplication at once. Now the question is there an order to how we do the reduplication? Do we have to do partial first and full second, or can we do full first and partial second? Or does it even matter? So let's investigate this. And here's how we can do this step by step. I copy the data. And what I do is I create two pipelines. I say, okay, I'm going to start with the word marrow. And in one case, I'm going to do full reduplication first and partial second, and I'm going to see what we get. And in another case, I'm going to do partial first, and I'm going to do full second and see what we get. And hopefully this will tell us what order reduplication happens. So marrow, we do full reduplication, so we get marrow, marrow. And when we do partial reduplication, I guess we're taking the first sounds, so we get m, marrow, and then marrow. So essentially we're just going to reduplicate this part. So our final result is mamero marrow, to mean little boys. But that is not what we get above. So it looks like full reduplication is not happening first. What about if we start with partial reduplication? Okay, so first we reduplicate the first consonant and vowel. So we get m, marrow. And now we're going to reduplicate the entire word. And we get mamero, mamero. And this matches what we had above. So if there's an order for how reduplication has to happen in this language, first partial reduplication and then full reduplication. So it's first doing singular to plural, and then it's adding that little meaning to it. Okay. A second question we could ask here is, how could we model this? So we're not modeling marrow to mamero, mamero. What we want to do is say, okay, how do we get from singular to plural? So how do we model partial reduplication? And then how do we model full reduplication? Well, the nice part is that with full reduplication, so I'm just going to make a new page with everything here. Get rid of all that. Okay, so we already know how to do full reduplication. We take a word, in this case these are nouns, and these are just going to double up. And the meaning here is going to be like little something. And this is just whatever x is. But for partial, it's different. So what's happening here? Well, the first consonant and vowel are being reduplicated. So if we have some word form that starts with the C of V and then the rest is whatever, and this is a noun, we can alternate this with CV, CV, and everything else, which also remains a noun, and this has plural meaning. So when we do partial reduplication, we're saying we're going to repeat the first two consonants, sorry, not the first two consonants, the first two sounds. So let's identify those as C and V, and then we'll just put them back to back. And then whatever else is here is the same. So if this is ta, and that's ow, then we get ta, ta, ow, ta-tau. While in this case, on the right, if we have marrow here, we would get marrow, marrow when we reduplicate it. So these two together can give us all of our cases here. Now here's a question is, can we do it in the morpheme-based model? And we probably could. Let's say we have marrow here. We could add some reduplication prefix or suffix and say that we get some result. But, you know, does the reduplication happen before? Does it happen after? And like, how much do we reduplicate? We have some problems there. The word schema model absolutely works. And it does seem more elegant than the morpheme-based model, because with the morpheme-based model, we have to do some weird things to make it work. And near the end of the course, when we talk about morphophonology in detail, we'll see another way to do reduplication that might be more elegant than the word schema model. That'll be up for you to decide. Now finally, one of the last exciting patterns we're going to look at is called a duplifix. And this is like a combination of affixation, hence the fix, and reduplication, hence the dupla. So something is being taken from the base and something is being added. So let's just take a look at this data. We have boog to boog-ag for the plural form, so singular to plural. Fool to fool-al, kub to kub-ab, jid to jid-ad. So what's happening here? Something is being added to each of these words. It's this bit right here. So an ah is being added in every case. So let's just say that this is the base for now. This whole thing, these are the whole base. We get x, whatever x is. We're adding ah, and then we're adding some consonant. So G, L, B, and D. But what's determining that consonant? Well, it's the final consonant in the base that's determining it. So we need to identify that the consonant in the base is the same thing as the consonant being added in whatever is being added on the end of the ah. So we can single out this consonant C, put an X for everything else, and then say that we're adding AC. So in this case, we have some word form in the singular that ends in a consonant. So this is a singular noun. The C here, XC, is basically saying it's some form that ends in a consonant. And then, to form the plural form, we take our original base, X and C, we add the sound ah, and we repeat that last consonant. So, for the example here, let's say this is G'd, D is the last consonant. Well, we repeat JI for X, we get D for our first consonant, we add the A, and then we add D again to get G-dod streets. So this rule is a duplifix. So it shows reduplication by using one of the items in the base twice, and it shows affixation by just inserting another sound after that base. So the base would be this bit right here. Okay, we're going to see a problem with that soon. The last thing we'll talk about is conversion. Conversion is a very uninteresting process. So basically what happens is you have a word like bottle or fish or kid that is one category, and you can use that same word as another category, either with a stress shift or with no stress shift. So I have a bottle, I want to bottle something. It's pronounced the same. So what we can say is if we have some form X and it's a noun, we can create a new word that looks exactly the same, but it's a verb. So what's changed is the category of the form, but not the form itself. Yoruba has this with adjectives and nouns, so properties and descriptions. So a property of something might be that it's long. Sorry, the description of something might be that it's long, and that property is length. So, or something is sweet, and the property is sweetness. So how sweet is something? In which case we have an X that starts as an adjective or noun, and it can be replaced with the same form that is the other category. Now with the morpheme-based model, we can do this. So let's say we have fish, and that's let's say it started as a noun. Now how do we turn it into a verb form? Well, we can say there's this unpronounced morpheme that converts nouns to verbs. And that's how the morphological model does, the morpheme-based model does it. Whether or not you like that, that's up to you. It seems, as always, if you don't agree with the 0 morphemes, then you might have an issue with that, but that is how the morpheme-based model solves it. So if we want to do conversion, you can try these questions yourself. With the morpheme-based model, we might do a word like bottle, and sorry, I won't use there's IPA for bottle. This is a noun, and this has the meaning of bottle. So that's how we could do it in the morpheme-based. But how do we do conversion then? Well, we'd have to do this 0 morpheme. So it's not pronounced. It attaches to nouns, and what it does is it does verb form of whatever the noun is. So that could be how we do a morpheme-based entry for that. With word-based, we just did that before. So X noun becomes X verb. Okay, so here's a data set. Pause it. Basically, what you're doing here is you're getting a data set and you're doing whatever you can to describe the data. Word-based model, morpheme-based model, however you want to do it. So I'm just going to give the answers right now and talk through it. So my first goal is really to describe what's happening. So I'm just going to box the stuff that's common just so I can focus on the new stuff. So let's just focus on 1 and 4 and start with an analysis for that. Sorry, this should just be Shinga. Okay, so what I see with, I'm going to just pronounce this as Kizzle, the Q, because I'm not very good at the uvular stop, Kizzle. So Kizzle becomes Kip, Kizzle. Shinga becomes Sheep, Shinga. So what I'm noticing, and just going through number 3 as well, looking at Turgen, Tup Turgen, all of these, whatever the base is, it's getting a P right before it. And there's the same first consonant and the same first vowel appearing before it. That's what I'm noticing. So, for example, if we have this word here, Kizzle, what's happening is we're getting the same thing to start, but we're adding a P, and then we're taking these first 2 sounds and we're repeating them. And all of the other ones work the same except for 2, but 2 doesn't have a consonant out front, it just starts with a vowel. So now that I've figured out what I'm doing, it's trying to figure out how to model it. So I need to talk about these 2 first sounds of the base. So for the base, I'm going to model this as CVX. So this will be the first form we have, red, long, quickly, thin. I'm just going to call these all adjectives for the sake of brevity. And I need to do some duplifixing here. So we're keeping our base. The base is not changing. But what we're doing is we're adding P right before the base, and then we're reduplicating those first 2 sounds. So our adjective is being changed to an adjective. Except our CVX is becoming CVP, CVX, which means these first 2 sounds are being reduplicated and a P is being added. But in the case of 2, we don't have a consonant at the beginning. It's just a vowel. So what we can do is we can say, oh, this first consonant is optional. If it's there, use it. If not, ignore it. And we can do that by putting brackets around it. So our final output, again, if we just write this a little bit nicer, is we have a form of the base, CVX, alternating with a form where, I'll make those parentheses a little bit less curved, where the first consonant, if there is one, is reduplicated. With the vowel, a P is added, and then the base remains the same. Okay, a little bit more difficult because we're putting things together, but this is just another example of a duplifix. So there's some extra slides about the morpheme-based models. Just as a reminder, the morpheme-based model essentially gives us rules through lexical entries. It doesn't tell us exactly how we combine things, but it gives us the lexical entries, and it allows us to use tree structures to combine things as necessary. And this is all done through concatenation. So the morpheme-based model is really focused on concatenation. And this model exists because concatenation is the most common pattern across languages that creates words. So it makes sense to think of morphology as being concatenation-based. It also resembles syntax in a lot of ways, how you can create words from rules, you can create sentences from rules, so a model for morphology should look like something from syntax. But what we found was that with base modification, we need to posit a bunch of zero morphemes, empty unpronounceable morphemes, which just doesn't seem satisfactory. And with other problems that come with it, the question is, well, how many different zero morphemes do we have? Because we have exceptional nouns for plurals, so we need a zero morpheme for plural. We have exceptional past tense forms, so we need a zero morpheme for the past tense. If we have base modification, we have a bunch of other zero morphemes for those different types of base modification. And we don't want to posit like hundreds of different zero morphemes for a language. In terms of the word-based model, it doesn't really express processes or rules. What it just does is says we have word form X, word form Y, these have different meanings, and you can go back and forth between the two. So it's nice in that sense is that we can look at word forms as a whole. So it deals with base modification, back formation, all of these things that change the base really well. So non-concatenative morphology. It can also do concatenative morphology, as we saw with X versus Xing with the jumping example, but it doesn't say that this is a morpheme, that ing, that ing. So it cannot represent affixes in isolation, which is a problem for us because we know that they exist. And in a lot of cases, if we want to specify the exact words that apply for any given rule, we need to add restrictions. And sometimes those restrictions are difficult to figure out, or there are just many different exceptions. So these are things that we'll keep in the back of our minds as we continue forward. I recommend doing the practice problems to do this. And of course, assignment 2 is coming up. So if you have any questions, as always, email me or post on the discussion board or post on Discord, and I'll get back to you when I can. But hopefully that was a good overview of everything we did this week.